Hello, everyone. My name is Inkyu. I'm a professor at Korea University. First of all, please excuse for my voice because my voice got hoarse after I got a cold. So please bear with me. Today, I'm going to talk about how the artificial intelligence (AI) technique can be applied in next generation communications. So briefly, I'm a professor at Korea University. I got PhD at Stanford, and my supervisor was a professor. He just stepped out. It would be a little bit awkward to give a talk in front of a supervisor even after I got a PhD 30 years ago. I'm an IEEE fellow and a member of National Academy of Engineering in Korea. Oh, sorry. And also, I'm a founding member of Korea 60 Forum. And so I'll briefly explain the 60 Forum activities in Korea, and then I will explain the AI techniques as a potential solution for 6G systems. So I will introduce you how LLM, large language model, can be applied for a 6G network optimization. And then actually this work will be published in the upcoming IEEE Communication magazine, and this work has been done with some of the collaborators, and including the Professor Marianne Deba at UAE. And so after I explain the activities in 6G Forum Korea, then I will give a more detailed explanation on the LLM work. So, as I mentioned, I'm a founding member of the 6G Forum in Korea. Ministry of Science and Technology in Korea initiated the 6G Forum about 2 years ago. As you know well, South Korea is the first nation in the world which realized 5G commercialization back in year 2019, and we try to maintain the leader position as a forefronter for the next generation as well. So our mission is to provide an open platform for leading 6G technologies. And in the 6G Forum, I'm in charge of the technical research, specialized in the AI. And our forum consists of several participating members, including the Samsung and LG, and then several telecom operators, and also as well as university institutes. So we try to come up with a vision and direction for the next generation 6G. So within this framework, several researchers trying to come up with a good idea on the 6G network. Nowadays, everybody want to work on the AI, but as far as AI for 6G is concerned, there's not a clear picture, and a lot of people talking about the AI, but still people don't know how exactly AI can be realized in the 6G system. So in today's talk, I'll give a brief idea on how it can be realized. So ever since that ChatGPT was introduced about a year ago, every researcher jumped into in this topic to get involved in the direction of 6G. So as everybody understand that in 6G, we expect that characteristics will change it from the human-centric to the machine-centric. So in many cases, people know how to solve the given network management problem. For example, people know how to solve the optimum power allocation problem in the interference channel. It's very well known. But why do we need to apply AI when you already have the solution? One question can be, we can ask one question. Is it possible to apply the AI when there's no knowledge is given? For example, we can solve the problem by using nice optimization mathematics, but we need to have a very detailed knowledge, such as channel state information and specific network configurations. But is it possible to solve the problem when those information is not available? Actually, there's an approach which can apply such a problem based on the genetic algorithm. For example, the genetic algorithm can solve the problem without getting any specific information. However, genetic algorithm requires a lot of extensive human intervention. Every time you get each iteration, you need to check the solution, and then you need to apply some hyperparameter fine tuning. But people realize that ChatGPT, large language model LLM, such as ChatGPT, may allow such a black box operation without having any system knowledge. So in this work, I will introduce a way of solving problem based on the large language model, which require no human intervention. So this is the idea how we can applying the LLM in the future network. Consider the multi-cell environment. So basically, we want to solve many things in network management. For example, how we can perform the user association and how to obtain the optimum power allocation for each user. And in traditional system, we can do that by utilizing the well-known traditional mathematics-based solution. But in the future network, maybe it's desirable to run the autonomous system, which do not require any specific information. So suppose we have a LLM installed in each base station, and each base station LLM can exchange. We assume that each LLM can exchange information among adjacent base station, and only based on the observation obtained from the information exchange, maybe LLM can determine the solution close to the optimum one without requiring specific information, such as channel information, CSI. So in order to achieve that, people realize that, sorry. How can we use 5 minutes? Okay, I'll make it quick. So there's a technique called in-context learning. So in the prompt engineering, we ask LLM to come up with a good solution. So in this case, in the in-context learning, we provide the input and example of the good solution. And then we ask LLM to come up with a better solution. So we ask, can you do better than this? And LLM can provide a solution without knowing that any specific configuration or specific information. So actually, this idea has been known in last year. It was published by Google DeepMind in ICLL. So it's a simple LLM optimizer. This is the first work that applied the LLM to be for the engineering optimization problem. So they iteratively repeat this loop, and they keep updating the in-context learning prompt. So we ask this question, and can you do better than this? And it is interesting to note that we do not provide any information. We do not tell LLM that this is for the power optimization, or we do not tell LLM about the channel condition. But interestingly enough, they explore the space and they can come up with a good solution. So this is a work based by Google DeepMind, and then actually it's not difficult to optimize with a single LLM, but it's more challenging to apply in the multi LLM case. So we can try to coordinate the information exchange among LLM. So conventional system requires a centralized one, which may not be feasible. So in this case, we come up with a new idea to efficiently coordinating the information exchange among LLM. So right-hand side, we call it the decentralized multi-agent LLM, which is called the D-model. So I'll skip to the detail, but I'll show you the structure of our system. So assuming that we have m different base stations, and each base station compute their local solution, and then exchange the local solution to the neighbors by having careful design. This is the final result. So the y-axis shows the relative spectral efficiency. So optimum spectral efficiency for the interference channel is well known that it can be generated by the weighted MMS algorithm. This is optimum, theoretical optimum. But without telling any channel state information, LLM can provide approach the optimal solution, but it takes more inference time. But our conclusion is that our decentralized algorithm allows to achieve almost the same optimum solution without telling any side information. So this is only the very early stage of how LLM can be applied in the future generation, and there's a lot of still challenges to be raised, such as how can we reduce the computation complexity, and how we can extend to practical network-based problem. So it opens up a lot of opportunity for the interesting research in this area. Okay, thanks for the attention.